divide it up into boxes and predict what happens between those boxes. That's what a weather forecast is. A weather forecast, and your forecast, which we see in 2 dimensions, is simply a snapshot which represents little boxes. So if you think what a weather forecast looks like, you can think that each box we are simplifying down to pressure in particular, because that's the visual way in which we see the reality. And that, in a sense, is the summary component of what happens. And we're just saying, right, this is what it's like now. Let's predict in an hour's time how that energy and that matter is going to move from one part to another, one box to another box. So we're in a box over Penryn, there's a box over the Scillies. Now, an hour ago we had a box over the Scillies which had certain characteristics, temperature, pressure, moisture, etc. The model then says, right, let's see what's going to happen when that energy and matter is transferred from the box over the Scillies to the box over Penryn. And we'll say that that takes an hour. And your basic weather forecast is just, we run the physics of it, and the physics suggests that this is what's going to happen here. So in other words, pressure continues to get lower, precipitation gets heavier, gets lighter. That's the basic idea behind it. So we just, we are in a box. And the physics of it is simply saying what happens. And the mass is in a closed system, the energy is in an open system. So real climate models are just 3-dimensional assemblages of boxes, which simplify the movement of matter of energy using basic simple rules, most of which are based in the laws of physics. And this is the sort of image that we see, this is the sort of idea. So, if you think you've got, on the ground, you've got a box, level of resolution. Let's say so many kilometres, 25 kilometres by 25 kilometres. Actually, that's a bit bigger. Let's call this a 200 kilometre by 200 kilometre. What your model is doing is converting the whole of, say, the Northern Hemisphere or the globe into boxes that go up into the atmosphere, that also go down into the ocean. So, and then basically each of these boxes has its characteristics, its energy and its mass characteristics, which we can simplify down into pressure, into temperature, density, etc. All the basic things that we can measure. And then we just run the model and say, right, okay, let's make it active, and it's coming in this direction, therefore most of the energy transfer is in this sort of direction, or if we have convection, it's going up, if we have a high pressure, it's sinking air. Basic physical principles, let's just let this 3-dimensional thing roll. In terms of computation, what do you see as the basic problems when we sort of get to this stage of modelling? Because the idea is quite a straightforward one. That you represent reality by a box of which has certain characteristics. And according to physical principles, that if this box then has the box next to it, we can predict or suggest that given the nature of the environment, the nature of these characteristics, this is how it will flow through time. What's the basic computational issues, do you think, here?
Doesn't it?
Boundaries. Well, come back to boundaries. At the moment, you have to put a boundary around it. And it's easy to think of the Earth as a boundary because we know that we don't lose much. It's small. But that means you've got to go right high. And boundaries are a difficult thing to actually decide, because boundaries are different. Because if you've got a box that's divided by, say, land and ocean, you then have to make different assumptions about the relationship between that. But yeah, boundary conditions are one.
Doesn't it assume that everything in that box is happening exactly the same?
Yes. Why not? Why wouldn't it?
local factors that might change things.
Yeah, you bring it down to one of the key issues. We'll come back to that.
Boxes are huge. You're doing 200 kilometres.
Yeah. So what determines the size of the box?
Conditions within it.
Conditions within it. So ideally, you want a box